Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning.
Waalaikumsalam.
Waalaikumsalam.
Okay, clear?
Yes, sir.
Today we are going to continue with our discussion. Okay, the topic that we are going to discuss is sequential logic structure. Okay, if anybody already going through the books, the digital book that I gave last time in the WhatsApp kan. So actually we are skipping the chapter 4 chapter 4 in the book, Introduction to Programming Structure. We are going to entirely skip so we are just move this chapter behind because as we discussed this before, we discuss the sequential logic structure, decision logic structure, and another one is loop logic structure. And before we discuss these three first, okay, we are not going to understand the chapter 4 punya content because that one is rather be advanced punya topics Okay. So in the book, sequential logic structure is in chapter 5 that one book Right. In order for you to understand this topic, first what you need to do is you need to understand how to extract the variables from a given case study or given problems first. Okay. The first step is you need to know in the given case study or problem, okay, before we develop our program, what are the key variables what are the key variables that you should extract from the information given that's the first step. So if in previous lecture you still don't understand how to get the variables, how to differentiate variable and constant, and then how to create equation or expression. So probably you will understand this the content of this chapter sequential logic structure. Okay, can you see my slide, my shared slide?
Yes.
Okay.
Yes.
Yes.
Yes, sir.
Yes, sir.
Okay, good. Okay, the subtopics in this chapter, the first one is a brief introduction about sequential logic structure. And then what is Psc, Ic and Ipo, pseudocode and algorithm, desk checking and flowchart. These all related Psc, Ic, Ipo, pseudocode algorithm, desk checking and flowchart. It is all related. So before you can develop the flowchart, first you need to develop the Psc, Ic and Ipos. So you need to know how to use these three. Okay, these three are the very basic first. Okay, before we develop the design of our program. So what is sequential logic structure? Okay, there are three main structure. Okay, in the program. The first one is sequential logic structure. The second one is decision So this we already discussed last time And the third one is what? Ingat tak? The third one is looping looping. So what's the difference? Okay, for example, yeah. For example, a calculator application. Okay. Saya nak share calculator dekat PC ni tapi tak boleh pula. So I'm taking a calculator from online calculator. Alright. Let me share this screen to you. Calculator. Okay, this is calculator from Google search kan. Okay, let's say if you have a basic calculator kan, the button that we have only this part, right? The numbers and then the operator and equal symbol kan. Let's say we just focus on this first. Okay, let's say we have a calculator with only one operation, allow only one operation, which is plus only kan. So what we need to do if we want to calculate two numbers kan. First we enter 1 and then sorry. Okay, so we enter 1 and then we hit the button plus lah. Okay, let's say there's only one button for mathematical operation, which is only plus. Okay, there's no minus, multiplication and division kan, tak ada. So there's only plus button. So you hit button number, let's say 1, and then you want to plus with 3. Okay, and then you click sama dengan kan, equal to what? So this is the answer. Okay, then let's say that's all the calculator can do. So you cannot repeat. You cannot, somehow this is a very traditional calculator, very basic. You cannot enter anything, any other operation kan. You tak boleh repeat the calculation. Okay, if you want to repeat the calculation, you have to close the application. Okay, let's say you have to close the calculator and then you have to reopen again. Okay, so you cannot repeat the operation, and the operation only can do plus operation. Okay, addition. Okay, addition operation only. So this is what we call as sequential logic structure. Can you understand that? Boleh Okay, and then we open. Okay, we upgrade this calculator by open up additional button. Okay, ada 3 more buttons. Okay, the division button, multiplication button, and minus button kan. So we have 4 buttons. Originally we have only 1 button, which is addition. Now we add 3 more buttons. So all together we have 4 buttons. Okay, for the calculator. Boleh nampak kan? Can you see my calculator? Boleh kan?
Boleh.
Okay. But the limitation is still the same. So you can only do one operation, and then if you want to do the next calculation, you need to close the calculator and you need to reopen again. Okay, so it still doesn't allow to do the repetition. Okay, so what you need to do, what you can do is, now you can enter first number and then you can choose. You can choose what operation that you want to do. Okay, this one of these 4. So let's say if you choose multiplication, so the system will calculate multiplication. If you choose addition, the same number but the result is going to be different. Okay, so user can choose. Okay, so when user choose, the application or the calculator also will react based on what the user already chosen. Okay, so the equation or the expression is going to be different based on user entered which button. So there's a decision to be made by the system, okay, based on user inputs. So that one is decision logic structure kan. Decision logic structure. So another one is looping. Okay, looping is where the system or the application allow you to repeat the same process over and over again. Okay, for example, in this calculator, once you finish with the calculation, you can straight away enter next input. Okay, and do any other operation. Okay, enter again. Okay, enter again. enter again kan. For example like that. Okay. So that one is what we call as looping. Loop logic structure. Okay, understand Understand the difference. So today discussion is mainly about the first structure tadi lah, which is the sequential logic structure. Alright. Now, sequential logic structure, decision logic structure, and loop logic structure. All these three, before you can develop the actual structure tu kan, apa benda structure ni kan. Before you can develop the structure, first you need to develop all these four elements first. So decision nanti, okay, when we come to decision, also you have to develop Psc Ic Ipo, pseudocode or algorithm, dash checking, and flowchart. And then we develop the decision logic structure. Okay, for loop logic structure, also the same process. Okay, we are going to repeat this process. Right. So during this first discussion about Psc Ic Ipo, algorithm and dash checking and flowchart, we are going to discuss in detail. But when we enter the next chapter, which is diffusion and looping logic structure, we are just going to reuse the information that we get from this chapter in order to extract all the important information. Right. So this is, as I mentioned before, what is a sequential logic structure. So it is the simplest logic. Okay, it is without decision and without looping. Okay, and then what is a Psc Ic and Ipo? So this is used to analyze the problem. Okay, so in real world, usually we are not going to use all these three. So it is either we use only one, for example, Psc only, or we choose we use Ipo only, or maybe the combination of maybe Ipo and Ic, or Psc and Ic. No, we are not going to use all these three. Okay. Okay, so moving on to the PAC first. Okay. Ini you can read by yourself lah. Okay. Okay, PAC. Okay, so what is a PAC? PAC is actually just a table. Okay, one table, as you can see over here. One table divided to 4 sections. So this is a PAC.
Sir, tak nampak.
You
Screen
nampak apa
masih
sekarang?
dekat Google.
Ya ke? Okay, sorry. Baik, cakap kan, kalau tak sampai habis lah. Saya dah sampai ni lah. Okay, this one okay, tadi sini, this one I explain about the need of Psc Ic Ipo for not only sequential logic structure but for decision and loop logic structure as well. Okay, so now we are going to look at the main difference of Psc Ic and Ipo. Okay, so what is Psc? Psc is about one table, okay, with 4 sections. Okay, so the first section, the title is a given data. So what should we put in the first section? Okay, first it should be the inputs of the program. Okay, the program that you want to develop, the input you should put in section 1. An input, for example, the calculator. The calculator that we discussed earlier. So what are the inputs?
The operand.
Yeah. What are the
operand.
inputs? Yeah. Sorry.
Operand.
The number. How many number?
2.
2 number. Okay, as we discussed last week, if you want to make it a variable, so how many variables should we put inside of the given data? How many? How many
4.
variables? 4 variables. Given data is mainly about input. Okay, input or input lah, depend on your problem kan. So what are the input? Or what is the input?
The number.
If you translate it to variable, the first input is what?
Integer.
First number.
First number.
First number.
First number, okay. Or you can put any names for the variable as long as you follow the rules for naming a variable kan. For example, no one, number one. So we know it is representing number one. Next is what?
Number 2.
Number two. There are two numbers kan? The calculator. You want to do calculation for two numbers only. The calculator. And then what else? Lagi.
The operation.
Operation is input.
The operator.
The operator. So user need to choose the operator, yeah, right? But what if it is a sequential? Okay, we are taking the example for the sequential first. The one that available is only operator addition, right? So user doesn't have any choice. The user cannot choose, meaning that there's no input. Okay, faham tak? If user can choose, then definitely there will be another input. For the case of sequential, user cannot choose the operator, so it will remain only two variables. Should we put answer over here? Is it correct?
No.
Answer is what?
Result.
Result.
Answer is result. So where will we put answer?
The required result.
Yeah, correct. So required result is where you put the variable that is related to the output. Okay, so this is where you put your output inside of the PAC table. Okay, let's look at the calculator again. Okay, so I'm going back to the calculator. Okay, and let's see. Okay, 1, 7 plus 3 equal to 10. So what is the value of variable answer?
10.
10.
10. Okay. Is there any other output from this screen?
No.
Ada tak? Tak ada Confirm?
Confirm.
Confirm no other output than answer.
Confirm. Yes.
Okay. What is output? Output is the thing that user can see. So what you can see over here? Is this
The
only answer?
question.
The answer, the value.
Is it
7
it's not only the value
plus
of
3
answer, right?
equals
You can
to
also you can also see the value of 7, which is The value for what? What variable?
Answer one. Number
7
one.
is what variable? Value.
Operand.
No. No
Huh?
one.
Number one.
No 1. 3 is what value?
No two.
No
No,
two.
two.
No 2 value. So you can see this. Okay, when user can see all this value, meaning that inside of the PSC, you need to put it in the output section. Okay. Can you understand that? Okay, unless unless if your calculator, if you are using this kind of calculator, can you see the image of the calculator? Huh?
Yeah.
Yes.
Yes.
This one, right? Okay, the basic calculator, when you do any operation, okay, it just show you the output, the answer only. Okay, it doesn't show you the numbers that involved in the operation. Okay, 1 plus 7, it doesn't show over there, right? It shows only the outputs, the answers. Okay, one variable only. So this one, if you put it in the PSC, you just put only one variable. Okay, but for the calculator that we use, okay, from the Google, okay, so it shows you all the numbers involved in the operation. So if that is the case, you need to put all the numbers together. Okay, faham eh? Okay, so it all goes back to the requirement. So requirement of the program. Okay, in your case, if during the exam, it will if the question mention about sample output and then it show the sample output consists of number 1 and number 2. So inside of your PSC, you need to write down number 1, then number 2, and answer. If not, then you can just put on answer only. If there's no specific outputs mentioned, okay, for the program, you can just put answer. Okay, otherwise you need to put everything. Okay, processing required. List of processing required, including equation or other types of processing. So what are the things that we need to put over here? In our case,
Jalan kira.
what is the jalan kira? What is the equation?
Because
No
it's
one
the
plus no
process.
two.
The equation that is understandable by the computer.
No one plus no two.
It is. Is it?
Yes. Yes.
To get what?
To get answer.
Bukti.
Huh?
To get answer.
How to get answer?
Sama dengan.
Yeah.
Answer equal
Okay.
to.
So you have to put the correct equation. If you do like this, for example, if you forget how to do the proper equation, so you do like this. This one is wrong. Okay, you will get 0 for this section. So the correct way is answer equal to number 1 and number 2. So if your program involving more than one equation, so list all the equation over here. Okay. If you have more than one equation, so list all the equation over here. Okay, understand?
Yeah.
Okay, solution alternative. This is quite confusing what to put over here. Okay, the basic that you can put is you can define whether the inputs for this program, whether this is the default. Okay, this is default for every PSC. if you are not sure what to put, you just put what are the inputs. Okay, Okay, and then we define it as constant. Or you can define all this input as normal variable, which is input value. Okay, when user can change the value, it is not a constant kan. So how to change the value? By inputting the value lah. So if these are the inputs that user need to enter. Okay, so it is not a constant. Okay, so this program can be a fixed calculator, a fixed calculator yang kekal kan. For example, calculator tu always, every time you run the program, it will only calculate 10 plus 10 only. So it is a constant calculator kan. Sorry, this is number 1 and number 2 lah. The input kan. It's a constant calculator. Okay, the number 1 always going to be 100 for example. Number 2 always going to be 10. So every time you run the calculator only give you the answer 110. That's a constant calculator. Okay, so we are not going to develop this kind of calculator. So this is the correct choice. If we don't have other alternative, this is the alternative that you can put. Okay, so number 1 and number 2 we declare as normal variable. Okay, which user can input the value. Okay, understand? This is the default for solution alternative. So let's say if you have other input, so you just list all the inputs over here. Okay, as constant and list all the inputs as value. And we put a star so that we know that this is the solution that the best for this program. Okay, the best solution is this one. Okay, play.
Yes.
Hello.
Boleh.
Okay, boleh
Boleh sir.
Boleh sir.
Okay, good. Okay, next is interactivity chart. So this is by far is the general, what we say, general information that our program needs when we are using a function. Do you still remember function? Last week we already discussed a little bit about function kan? Ada tak?
Yeah.
Ingat tak?
Ada.
Remember?
Kena repeat balik. If you remember my
Yes, sir.
drawing last week kan?
Ingat.
Ingat kan? Tak apalah, saya lukis dah balik. Okay, if you remember my drawing, so if let's say we have one program kan? Okay, one program. So one program can be only one program, or we can divide it into several modules, okay, which is we call it each module as a function. Okay, for example, we have 3 modules. Okay, for calculating tadi kan, additional kan. So this is program to add 2 numbers. So we have input module, and then we have calculation module, and then we have output module. Okay, so we have 3 modules combined together to become one program, which is additional program. Okay, you get it? Boleh nampak So there are 3 modules. Okay, there are 3 functions. So where we declare all these functions. Okay, this is the completed one. Okay, this is the complete program kan. But before that, this is the reverse engineering Before that, before we design this program, okay, we have to come up with the IC, Interactivity Chart. Okay, Interactivity Chart. So what is Interactivity Chart? Ni lah. Okay, So I'm moving back to the slides. Can you see the slide?
Yes.
Boleh nampak? Boleh nampak slide?
Yes.
Okay. So this is where you imagine. This is before the program is completed. So this is the first step before we design the program. We imagine. So how many modules should we create inside of our program? Okay. So in this case, the basic one is 3: read, calculate, print. It can be more. Okay. The basic is read. Read is the input. Okay, input module. Calculate is a calculation module, and print is where we display the output. Okay, the output module. Okay. So for interactivity chart, all this module is controlled by the main module. Okay, nanti bila once we do the programming, so we will learn about main module or main function. So main function is the one that control all other function. So dia mesti on top of the IC, okay, interactivity chart, you must have the control. Control macam ni lah. And what are the numbers inside of each of these function kan? So this is how to represent the level of the function. Okay, for example, control must always start with 0 lah. 0, 0, 0, 0. Okay, must. Okay, because it is a control. All programs should start with control. If you have more than one module or function inside of a program, nak start yang mana satu modul kan? So dia mesti ada the module that trigger all other modules. Okay, so we are always start with control module or function. That's why you put 0, 0, 0 number over here. And then for level 1, okay, level 1, ni level 1, dia boleh ada, it can have more than one level. Okay, for the next level, which is level 1, okay, the first module we put 1, okay, and then 0, 0. Okay, the second module 2, 0, 0. And then third module 3, 0, 0. Boleh? So is this number important? Not really, but you need to know. Okay, what is the important part in IC? The name of the module. Okay, the name is important. Okay, numbers is not very important, but in case us in the assessment you need to know. Okay, okay, right. Calculate, print. Boleh. Okay, next, what happen if we have another module? Okay, another lower module. So let's say we have over here, calculate. You nampak kan? Contoh lah kan. For example kan, we have calculate. This one calculate 2, this one calculate 3. So all this is under the module calculate. For example something like this . So what should be the number?
For the left to 100.
Alright, so calculate 2 to 100, calculate 3 to
200.
200. Okay. Boleh . So meaning that how many module we have in our program?
5.
Ada 5 lah. Not 4, not 3 anymore. So we have 5 sub module. Okay, so this is where we define all the modules or function involved in our program. Okay, next. Okay, next, once we complete with the module design, okay, this is just a brief design, so it may be changed, okay, during the development process of our program, but we have to have one basic structure lah for it, okay, to move to the next process, Okay, next, once we finish with the IC, okay, we develop a IPO table, input processing output table. So if you see, okay, IPO and PSC is quite similar, right? We have input, we have input for PSC, and then we have processing, processing in PSC also, and then over here the addition is on the module reference number or name. Usually we use name lah. Number, if the question asks you to put number, you put number. If not, we use name. So module reference is referring to the IC. Okay, module reference is referring to the IC. And then output. Okay, output moving back to PSC. Okay, so output is the same. Okay, so input. What should we put over here?
No 1, no 2.
Number 1 and number 2. Yeah, correct. Okay, so all the inputs. Okay, in this case, number 1 and number 2. What should we put in the processing?
Answer equal to no 1 plus no 2.
Yes, correct. That is one of the item inside of processing. But before that, before that, so IPO is actually the detail part of PSC. So you need to detail out. Okay, for input number 1. So what you should do for number 1? Okay, so you should put enter. For example, number 1. So who need to enter? Of course, user kan. Okay, so the keyword is enter, either enter or read. You can use enter, you can use read number 1, or you can use input number 1. Okay, all the keywords that when other people read your IPO, they will know that it is an input process. Okay, and then the second one is enter number 2. Okay, you get it? So finish with entering all the inputs, then we move to processing the answer. Itu je. It can be brief or you can put the equation for answer. Calculate answer equal to number 1 plus number 2. Okay, but if you do like this, also correct. This is already enough. Okay, so that user will know, readers will know the third step is to calculate the answers. Okay, to calculate the answer. So how to get the answer equation? Refer back to the PAC. PAC already given the detail of the equation kan?
So ada dua cara lah.
Yeah. It's up to you. Both are correct. Okay, next is next nanti kita hold dulu yang ni. Kita selesaikan dulu modul ni So module name from IC. So this is referring to the IC. So you need to take under consideration all the processing involved over here. Okay, all the processing can be put in what module? So right now we have, ini saya buang balik we have 3 module. What is the suitable module that we can put enter number 1? Process. Enter number 1 process. Modul.
Input.
Dalam IC kita modul apa?
Read.
Read. Okay, refer to your module IC If you put read, then it should be read. If you put input, then you can put input over here. Or if this is enter, then you put enter over here. So the name is read. So the module is read. Okay, the suitable module for processing enter number 1 kan. Boleh? Boleh?
Boleh.
Just
Boleh.
write down the module
Boleh,
name.
sir.
Okay, the next one is what module?
Calculate.
Calculate. Ke calculate? Read lah kan. Enter number 2. Still read kan? The suitable one. Faham tak ni? Can you understand class? The third one. Where we put calculate. So this is inside of calculate module. Apa betul? So this process is inside of read module. This one is inside of read module. Okay, this one is inside of calculate module. Okay. So what is the output? After we finish with the calculation, the output is going to be the, if we follow the Psc, how many outputs we have?
3.
Okay, if we follow the Psc, we have 3, right? Okay, number 1, number 2, and answer kan. So this is based on the Psc kan. If the Psc only give one output, which is answer, then the output here is only one lah. Answer only. Okay. Okay, so what is the processing for this? If we have input, there should be a processing. If we have a calculation, there should be a processing. If we have output also, don't leave the processing part empty. You must put the process. What is a process? Processing, process. Process. This is input, process, output. Processing ni process. So the process is, you belagak kan apa dia? Belagak apa? Print or display. Yang tu benda-benda lain lah, term lain. Display kan, display. Guna print pun boleh kan? Display number 1. In what module?
Print.
Yes, correct. Print module. Next. We have output for number 2. So it should display number 2 inside of module
Print.
print. Okay. And finally, we display the answer inside of module print as well.
Print.
Okay. Boleh?
Boleh.
Boleh.
Okay, and finally the process end by going back to the control. Control ni sebenarnya ada lah nama dia. Contohnya if let's say the program name is add kan. Add adalah. So add control. Kalau program tu namanya GPA. CPA calculator kan. So CPA control for example kan. So this is the name of the program and then control. Okay. So all program, if you have more than one function, it will always end inside of the control module or control function. So end should be goes back to the control. Faham?
Faham.
Then finish. Okay. Finish already. Psc, Ic and Ipo. This one is documentation only. Very easy. Senang tak? Senang kan?
Senang.
Senang.
Okay, good. Okay, nanti kita try buat latihan Tengok faham ke tak faham Alright, so this is example. Calculation for finding average 5 numbers. You can look at this. Okay, so can you read this? Example 2. A program is required to find volume of a cube. Okay, the volume of a cube. Okay. Please construct the PAC for this problem. Okay, from here kan, what is the memang nampak lah kesalahan dia apa What is the perfect error? The error that you can see from this PAC. The use of what? Ini minggu lepas punya.
Variable.
Yeah, the use of variable name. Okay. Over here, the age tu macam age tu apa? Dia punya tepi tu kan? Tepi cube tu kan? So it is using A kan instead of age kan? Boleh ke kita guna age je kan? Kan lagi senang kan? Maksudnya lagi accurate for the variable name. So instead of using A, which is not a good variable name, so you can use age kan? Age kali age kali age. So this is the correct. And then required result, volume of a cube. You can straight away use the variable name over here kan, volume saja boleh kan macam tu So solution alternative as you can see over here, the input is only one kan, so define age as constant kan, and then define age as input value kan. So which one is the best? So input value is the best for this kind of problem, for example. Boleh kan? Any question so far?
So far, I don't have any
Questions, sir.
questions.
Alright. Okay, I see as we discuss. Okay, I see. Okay, I see this is where I explained earlier. Same thing. Okay, with addition of this slide kan. Okay, this slide is where we apply decision and looping to the IC design. Okay, just a brief decision and brief looping information kan, not the detail one. The detail later on. Okay, so let's say if inside of our program, okay, we have control module 1, module 2 and module 3 as a basic module. Okay, next we have module 2 Okay, ada pecahan. Okay, so it can be either if you enter module 2, it can be either you will be the program is going to redirect to module 4 or module 5 based on some kind of decision. Adalah, let's say if the decision made to module 4, so it will go to module 4. If the decision made is to module 5, then it will go to module 5. If there's a decision that will determine which module to go next, then you need to put diamond symbol over here. Okay, if there's involved a decision, if there's none, then no need to put decision symbol. Alright, this is just a brief design. Okay, you think that it should be a decision, so you put decision over there. Okay, belum detail lagi kan, just a brief design of the function or module. Okay, and then if let's say after entering module 2, okay, you need to repeat the process of inside module 1, but the module is new module. The process is similar with module 1, but it is a new module. For example, kan, just copy and paste. Kan, nak buat apa pun tak tahu, tapi let's say if there is a requirement to do that. Okay, so the content of module 1 and module 4 is exactly the same. So it is a duplicate module. So you highlight the module, okay, by doing this. Ni lah. You put somewhere at the edge of the module, you put this, you highlight the module, like this kan. Meaning that it is a duplicate module. Okay, it is the same. Okay, the name is different, but the content is similar. Okay. Okay, and then if there's any looping involving inside of your module, let's say inside of module 3, there's a looping. Okay, you repeat 10 times for module 3 only. Okay, you repeat this module 10 times. 1, 2, 3, 4, 5. Contoh contoh dekat sini print module. You print answer. So you print 10 times. So adalah letak kat sini. Okay, you need to put dot over here, meaning that this module will be repeated. This module will be repeated. Right? Ni addition lah untuk IC. Okay, don't worry about this. Let's say if you are not sure kan, if you are not sure, then always go back to the basic. The basic module is this one. Okay, control, read, calculate, print. If you are not sure, you put down the answer like this, sure you will get some marks. Okay, don't worry so much. At least you put something, okay, inside of your answer. Don't leave it empty. Empty also, of course, you will get 0 kan. If you are not sure, then this is the basic IC. Just put this one. Okay. The IC can be written in 2 ways. The first one is the one that we already discussed, which is the procedural programming. Okay, top to bottom. It will start with control and then it will move downward. Okay, entering sub modules. Okay, for example ni kan. Okay, ini contoh repetition. Okay, ini contoh repetition tadi. Okay, contoh repetition, a system to calculate tuition fees. Okay, so the system is going to be repeated on what module? Read and calculate only, right? Okay, until no more subjects entered by the user. So as long as user enter subject, it will repeat these two. If user stop entering the subjects, what it will do? It will do the printing part. Okay, only print one things. Okay, So this is where you put the repetition part. Okay, so this is the procedural programming IC. Okay, interactivity chart for procedural programming. Okay, normal program. Okay. Another thing is if you ever heard of object oriented programming, okay, OOP programming. OOP programming, we are not going to discuss this in detail, but this is how it is going to be looks like. There's no structure, top-down structure. Okay, so the module is going to scatter away. Okay, mengelilingi control ni lah. Meaning that from one module to another, it doesn't have to go through control first. Okay, kalau macam ni, control yang akan start dulu, and then if you go to read, it will go back to control, and then control will redirect which next. Okay, but for this, let's say if you start with control, okay, you can move to module 2, module 3, module 6, and then module 6 again, module 1, or you can also start with module 6 straight away. For example, object oriented programming. So it doesn't fix with top-down structure like procedural programming. But we are not going to discuss this. There's going to be one subject for this one, object-oriented programming subject that we discuss on this. Okay, just so that you know, the basic structure for IC with OOP is something like this. Okay. All right. Okay, IPO. Okay, IPO. Any question about IPO?
No.
Okay. Okay, this is going to be your exercise. Okay, so I need you to do this and submit to Kalam. Okay, in the lecture week 3 section. Okay, do question number. Do one only lah. Okay, I think the first one is enough. Okay, do this question. Okay, Psc Ic and Ipo. Okay, do it in Microsoft Word lah. Kalau tak ada pun anything lah, as long as you submit. Use any platform also can. Okay, so IPO. Oh, dah ada answer kat sini. Tak apalah kan. IPO, oh dah ada jawapan Cancel. Nanti saya bagi soalan baru Okay, so next topic is pseudocode and algorithm. Okay, next is pseudocode and algorithm. Okay, so we finish with this one. Okay, finish this. So next step is to develop a pseudocode and algorithm based on information that we extract from the problem. Okay, information tu nak dapat dari mana? Daripada sini lah. Psc Ic and Ipo. So next step is develop the pseudocode and algorithm. Okay, based on the information from Psc Ic and Ipo. They related. Okay, pseudocode and algorithm. Okay, so the one that we are going to stress more, okay, in this subject is on the algorithms. Pseudocode ni tak guna sangat lah. Kita guna algorithm more, okay. Okay, algorithm. Tadi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120 So what is pseudocode and algorithm? Sometimes when you Google around pseudocode and algorithm ni, dia sebenarnya something yang quite similar lah. But in this subjects, we differentiate it by saying that pseudocode is informal. Okay, informal. Algorithm is more formal. Okay, what is informal? Contoh, kita tengok contoh kan. Let's say, okay, so pseudocode and algorithm is instruction. Okay, pseudocode and algorithm is instruction. So where we can see the list of instruction. So the list of instruction is something like the one we create inside of our IPO. Okay, these are instruction. Boleh faham? So what is instruction? These are the instructions. Kenapa perlukan instructions? Okay, you know that a computer program apa? Consists of a list of instructions, kan? For example, if you want to do a calculator, kan, to add two numbers earlier. So what are the codes for that program? Okay, the codes content of 1000 line of instructions. That what we are going to tell user lah. Okay, something like that kan. So all these instruction is listed over here inside of the IPO. So this is the early way to design program. So we list all the instruction first. Okay. Next, once we get this, so we turn it to algorithms or pseudocode. Okay, tahu dia bukannya kita create, it is not that we create from scratch, kan? It is step by step punya proses. Okay, kita ambil daripada Psc, Ic and then IPO, and then from IPO we take it and we convert it into a proper pseudocode or algorithm. So this is the instruction. Inilah kalau nak kata instruction. So these are the instruction. Okay. Okay, go back to the pseudocode. Okay, pseudocode. So this is the example of pseudocode. Pseudocode, as we said earlier, it is informal way to represent the instruction. So it will start with start, meaning that it is a start of pseudocode and with a number, 1 or 0 lah. You can use 1 or 0 to start a pseudocode. And then you just take everything that you put inside of the process column inside of the IPO, you put it one by one. Okay, read price of item. Okay, for example, if we take our earlier example kan, how to calculate two numbers, kan? How to add two numbers. So it should be read what? Read number 1.
No one.
And then read number 2. And then what next? Answer
Calculate.
equal to. Okay, this is what we said as in informal way kan. So we change the equation into text. Jangan nak change. For example, number 1 kan. Or maybe we use this number 1 because it is informal way kan. Let's say we use it as informal way kan. Number 1. Sama. Begini. Okay, and then this number 2. Informal kan. Number 2 or second number. First number, second number. Answer equal to number 1 plus number 2. Then print what? Print.
Answer.
Print not only answer kan. We print number 1, number 2, and answer. And finally, we close the pseudocode with AND statement. So this is pseudocode. Boleh? This is a very easy things to understand. Make sure you understand lah. Boleh
Boleh. Algorithm pun sama ke?
Okay, kejap. Algorithm. Sebentar. Okay, kejap. I put this. Alamak, tak boleh pula. Tak sebelah-sebelah. Boleh kan? Tak boleh. Macam ni lah kan. We are taking the information from here. Okay, from process ni we put it inside of our pseudocode. Informal way. Informal way, if possible, you have to make everything a text lah. Kalau di question panjang tu, you jadikan the text lah. That one is we consider as informal way. Okay? Boleh ini tak masuk modul lagi. Modul ni nanti kemudian kan. There's no module over here. This is a non-module punya pseudocode. Without a module. Alright? Okay, next. Moving on to algorithm. So what is algorithm kan? Algorithm is the same thing actually. The main difference is how you write. Okay. So this one we use for algorithm Algo. Algorithm we use variable. Okay, let's say the variable for number 1 is number NO1. Okay, the one that we list down inside of the Psc and Ipo kan. So we use NO1 for variable. So we put the variable over here. So this is not variable kan. This is informal way how we presenting the information. Okay. So next is number 2. Okay. So answer. Instead of putting it in a words kan, like this. So we put the exact equation. Okay, the exact equation is number 1 plus number 2. Okay, boleh? Yang ni print number 1, number 2, answer. Okay, and so this is algorithm. Boleh? Nampak tak beza dia?
So
Can you see
dia
the
informal ke formal?
This is formal. Okay. Algorithm is formal. Pseudocode is informal. Ni algo
So yang print
Yeah.
yang dekat print tu memang number lah.
Oh, sorry.
Number.
Baik cakap dia kena konsisten kan, ingat tak? Konsisten kan. So if you use NO1, ni lah, dia kena sama lah.
Okay. Thank you.
Okay. Okay, so this is algorithm. Boleh?
Boleh.
Okay, any more question? Any other question?
So
Ya.
algo dia pendekkan je lah.
Algo dia bukan pendekkan, dia formal kan. Dia make okay, algorithm makes the statements much more like macam mana syntax, coding syntax. Kan lepas kita dah buat ni semua, kita punya next step kan, ini maksudnya dah design tau, ni dah siap design tau. So next step is convert the design into a computer program. Okay, so computer program tu nak buat dia perlu ada syntax. Maksudnya ada cara kita nak type coding tu. Okay, so untuk algorithm ni dia lebih algorithm is much more similar to programming syntax. Okay, it is much more similar. Dia sikit lagi, okay. It is just a few steps before we can turn this into actual computer program. That's why we say this is a formal way to represent the program lah. Kalau yang pseudocode is informal way because we are still using word that apa kita panggil layman terms kan, that everyone can read it. Okay, everyone read it and then everyone can understand. Okay, what's the program supposed to do. Okay, but algorithm maybe not everyone can understand, but programmer sure can understand. That's the difference. Okay. Okay, in example 2, as you can see, there's a if statement kan. So don't worry about this first. I'm going to skip this since this is the elements of decision. So once we go to decision chapter, okay, we are going to this again, okay? I need to skip dulu. So now we just focus on the sequential part kan. Sequential without decision and looping kan. Okay. Sebenarnya itu saja untuk that's all about algorithm kan. Very simple because sequential is straight to the point punya ni kan, structure. So it is quite simple lah untuk algorithm. Nanti once we go to decision it will going to ada pening sikit lah. Okay, next, once we finish with the algorithm, there's one more element, okay, that you need to know, which is the dash checking. Okay, this is only for algorithm. This is only for algorithm. Ingat dash checking is what? It is a technique on how to check whether your algorithm is correct or not. Okay, this is where we verify our algorithms. Sebelum kita turn the algorithm into a real code, so we need to check whether the algorithm is correct or not. So how to check the algorithm? By using dash checking. Okay, so what is dash checking? Dash checking is just a simple table. If you can see over here. Okay, the first element need to be put inside of this table is the line number. So where we get the line number? From the algorithm. Let's say if we have this algorithm. Okay, simple algorithm. Circle to calculate circle area kan. So this is the control name lah, circle area. Kalau kita buat IC, this is the name of the control, okay. Circle area control. Okay, then we have process to, ni proses apa? Radius, meaning what? Is it input, process or output?
Input.
Input kan. So user need to enter the inputs for radius. And then this is a calculation. Okay, this is the calculation to get the value of the area. Okay, based on the radius. Okay, ini sepatutnya tak apa, kita tengok kemudian kan. Okay, and then print area. So this is the output. Okay, ni sepatutnya kalau based on dash checking ni, dia bukannya ni, dia adalah value. 3.142. Kenapa? Sekejap saya beritahu kenapa kan. Okay, next you need to list down all the variable involved in the algorithm. Kena listkan semua. Okay, you have to list all the variable inside of the dash checking. Where do you put all the variables? Okay, on the top of the dash checking. Okay, next to the line number. So we have line number. Okay, next element is variable 1. So the first variable is radius. So put radius over here. Next, second variable is what? Area kan? So put area. So if we have pi over here, so put pi. Since there's no pi over here, then it is not a variable. Supposedly it is a value. If we have pi over here, then you have to put one column, which is what? Pi. Faham? You need to list all the variable inside of that checking. Okay? Get it? Boleh?
Boleh.
Okay. Boleh. Next is input or output column. This is the last one. Okay. So it should have line number, variables, and input output column. Okay. Next, what to do? Okay. Next. Okay. Get a test data. Okay. Test data. Okay. Test data is where any random value for the inputs. Okay, you set the value for the inputs by yourself. You can put any value randomly lah, up to you lah. Okay, for example, in this case, the test data is 2 and 3. Okay, so for first set, we are going to take 2. We put it in our dash checking. Where to put 2? Where the input happen. So input happen inside of the algorithm in what line? Line number?
Second.
Second line. Okay, line number 2. So in our dash checking, in line number 2, radius have value 2. Because user entered this value. Where you get this value? From the test data. If the test data is 2, then you put 2 lah. So how the program gets this value? From the user. That is why we put, instead of input or output column, we put this statement, radius apa? 2. Meaning that this is input. Sebab ada sama dengan, maksudnya dia adalah input. Boleh?
Boleh.
Boleh kan? And then what happened in line 3? Line 3 is where we assign a value to variable area. Based on what? Based on this calculation. Okay. So instead of our dash checking, you put the real value of the equation. All the variable involved in the equation. Okay, so radius, the value is 2 kan? Okay, 2 times by 2 times by 3.142. Ini yang kita dah tukar tadi lah. We are not going to use this as a variable kan? Because if you put pi over here, you need to add one more column over here, which is pi. And then you have to define where you get the value of pi, 3.142. Macam tu kan? Okay. Boleh? Okay, next in line 4. Okay, line is very important for the algorithm because it will reflect on the dash checking lah. Okay, so in line 4, output happen. So ini tak boleh macam ni. It should have It should state what are the output where the output come from, area, besar slide ni. Oh, dia bukan dalam table ni macam tu lah. Ni area equal to 12.568. Okay. Okay. So first set, and then if the question asks you to develop dash checking for 2 set, and then you must have the second set. If the question asks you to develop dash checking for 3 set, then you should have the third set. Okay, boleh. And then you do the same thing lah. Okay. Okay, you track down the algorithm again. So line 1 is the name. Then line 2 we have radius equal to 3, kan? Okay, the second set. So radius equal to 3. So what are the process? Is it input or output? It is output. Input, sorry. If you see a question over here, question symbol, then it is a input. Okay, next in line 3 we do the calculation. Okay, line 3 we do calculation, and line 4 we do output process. So output, how to differentiate with input? Output we have equal to, kan? So this means that it is output process. Okay, this is input, this is output. Okay, so if we have more output over here, kan? For example, in the case of okay, our calculator program, kan? Mana pula calculator ni? Calculator. Mana pergi ya? Oh ni. Okay, calculator kan? Oh, saya tahu nak suruh kamu buat apa nanti lah. Saya nak kamu buat dash checking untuk calculator ni, okay? Boleh itu kemudian. Okay, next. Okay, next. Any question about dash checking? Straightforward, right?
Doktor.
Ya.
Checking tu memang kena ada 2 kali lah. First set dengan second set tu memang sampai 2 kali ke macam mana?
No, based on the question. Okay, if the question asks you to develop dash checking for 2 sets of test data, then you must have 2 ni lah. 2 table lah. Okay, dia boleh sambung je ataupun separate table. Okay, first table and then second table. If the question asks you to develop dash checking for 3 sets of data, kan, test data, then you must have 3 table. Okay?
Okay, thank you, Doktor.
Okay. What is expected result? This is result that you calculate manually, kan? Maksudnya ini before you develop the dash checking, you calculate manually, you get this answer. Okay? So when you translate your algorithm into dash checking, you get the similar answer. Meaning what? Meaning your algorithm is
Betul.
correct. Okay. That's how you determine whether the algorithm is correct or not. Alright. Okay, so this is another example. Okay, you can look at this later on. Okay, next is flowchart. Flowchart. Okay. So we finish with the dash checking. Okay, dash checking purpose is to check algorithm. Okay. Next, we move to flowchart. So what is a flowchart? Okay, PAC, IC, and IPO used to obtain requirement. Okay, requirement apa kan? Contohnya apa? What kind of input, what kind of variable, what kind of calculation involved. Okay, this is requirement kan? And then once we get all these requirements, then we design the program. Design program using what? Using pseudocode or algorithm. Okay. Then dash checking. Dash checking is to check or verify lah. Okay, verify algorithm whether correct or not. Okay. So how about flowchart? Flowchart is similar with algorithm. This is how this is design. It is alternate way to design a program. So it is either you use algorithm or you use flowchart to design your program. Either one. It is very rare lah if you design the program using this both. Okay, you develop algorithm and then you algorithm flowchart. Rare kita buat macam tu kan. Usually we choose either one. Either we use algorithm to design or we use flowchart. Either one. So it is actually similar way, but a similar way to similar thing, similar apa kita panggil? Tujuannya adalah sama kan. The purpose is to design, but using a different way. Different, bukan similar way kan. Different way to design a program lah. The first way is using algorithm. Second way is to using flowchart. So how to do flowchart? Flowchart, if algorithm is mainly about text, flowchart is about symbol. We use symbol for flowchart. Algorithm, text. Flowchart, symbol kan. So human kan, dia ada two types of human kan. First type is the one is excel in apa otak belah mana lah, tak ingat lah kan. If they look at a symbol or anything, they can understand more kan, compared if they are reading from a text. So this is to cater this kind of person lah. If you are more person yang lebih banyak berimajinasi kan. So this is for you lah. Okay. Okay, flowchart. So flowchart is there's a standard symbols that you need to know before you can develop a flowchart. Dia bukannya, it is not that you can use any symbols for flowchart kan. There's a official symbol for flowchart lah. Okay, the most common one is the lines. Okay, the lines is showing the flow of the process. So we are following the lines. Okay, when we read a flowchart, we are following the lines. If the lines ask you to go up, so you go up. If the lines ask you to turn left, then you turn left. Okay, and then we have start. Okay, there's only two of this symbol. Start, end. That's all. Okay, or start, exit. There are two je. Okay, either it is start or end. Okay, this is the easiest one. Okay, and then processing. If you have a calculation, so you put the equation inside of this symbol. For example kan, tak tahu kan. For example apa tadi? Answer kan? Answer equal to number 1 plus number 2. So you put this equation inside of this symbol. Ini tak apa. Start. Start. If it is the beginning of the flowchart. If it is the end of the flowchart, we'll put end. Okay. So what else can we put instead of the processing? Okay. Initialization of a variable. For example, this is just example. For example, if you want to put a value for pi, so we put it like this, pi equal to 0.142. So this is pula kan 3.142. Okay. We put a value to a variable, so we also use this symbol. Okay. It is for two operation. First, for any equation or expression. Second is for initialization of variable value. Okay. Contoh kan. Okay, next, the parallelogram. So this is for inputs and outputs. Okay, for example. Okay, for example, dalam inside of the excuse me. Okay. Okay, sorry. Okay, parallelogram is where you put the input or output. Okay, output and output using the same symbol. Okay, for example, read number 1. So we put it over here. Or print answer. Okay, we use this kind of symbol. Okay, decision is where we discuss about decision nanti kita akan gunakan ni. Okay, yang ni you just leave it first. Okay, decision nanti Okay, and then we have module. Okay, ni pun kemudian. Okay, we will discuss it later on. And then looping. Yes? Any question? Boleh soalan? Tak ada. Okay, this is for loop. Also, we are going to discuss this later on. Okay. Okay, connectors. Okay, connectors ni, if your flowchart is very long, okay, we use connector. Okay, for example, on page connector. Let's say this is your flowchart. This is not a complete flowchart. For example, this is a flowchart, and then ni A4 size kan. For example, this is A4 size. So, and then you want to continue in the same page, but on the right side of your paper, for example. So, this is same page. So, we use on page connector. Okay, okay, the flowchart will end with A, and then we continue again with A. Okay, on the right side of your paper lah. This is similar with, let's say, if you don't want to use connector kan, so you just delete this and then you just put a line over there kan, shape. Okay, put line macam ni kan. Contoh example lah, contoh kan macam ni kan. So this is similar lah. Okay, this is similar like you use on page connector, earlier on page connector kan. You use A and then A. So it is equal to this one lah. Sama flow dia. Right, this is on page connector. Then we have off page connector. If let's say your flowchart is very long kan, and then you have to continue in the new page. So new page using this symbol. Okay, so the name of the symbol should be similar with the one that will continue lah in the next page. For example, if you use A2 over here, if you use A1 over here, is it correct or wrong?
Wrong.
Wrong. Okay.
Wrong.
A2 should be A2 over here.
Itu juga.
Barulah dia bersambung. Okay. If you use A2 and A1, then that is incorrect. Okay, wrong. Okay, this is different page connector. Okay. Okay, so sequence. Okay, structure, sequence structure, sequential logic structure, flowchart. How to do it? This is the easiest flowchart lah. Okay, for example, if we have let's use our example earlier kan. We have algorithm. Okay, this algorithm kan. Okay. How to turn it to, can you see my algorithm? This is the algorithm that we discussed earlier kan, how to add two numbers kan. So we want to translate this into a flowchart kan. So start. Oh, sorry juga ni. Sekejap let me copy this first lah. Okay, let me copy this. Okay. Ni kan. Okay. Okay, start. And then we have read number 1. As I said kan, the wording here, it doesn't matter. You put enter, read, input, as long as it representing an input process kan, doesn't matter kan. So read number 1. So read is input. Okay, input is we use parallelogram. Tu kita sebut kan, this symbol. Okay, so we use this symbol for input. So we can just recycle ni lah. Read number 1. So this is the algorithm. This is the same same design but using flowchart kan. And then we have read number 2. So read also use this symbol kan. Input and output use the same symbol, parallelogram. Read number 2. We use this symbol. Nak guna tak this symbol? Index symbol?
No.
Should we use this symbol? No, right? The next process is the calculation, right? Okay, calculation is using this symbol. Okay, so this symbol. Okay. Okay, this symbol over here. Okay, the calculation is this one. Just copy this. Right. Nah, using the correct symbol. Okay, ni kan symbol for calculation. Okay, either calculation or initialization kan. Using the same symbol. Okay, next. Okay, next print. Recycle je kan. Malas nak type ni. Okay, next print number 1, number 2 and answer. Okay. Either you separate or you can combine. Okay, doesn't matter. You can combine or you can use different. Okay, different symbol separate symbol for different variable. Okay, for example, we have 3 kan, print number 1, number 2 and answer. So you can put this print number 1 and then new symbol, print number 2 and then print answer, different symbol. Or you can combine together. Boleh kan, tak ada masalah kan. Print number 1, number 2, answer. Kita elok sikit lah. Sini kan. And finally, end. So that is your flowchart. Okay, similar meaning with this algorithm. Okay, boleh?
Boleh.
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 Boleh. I think that's all. Okay, for exercise kan, exercise simple only. Apa benda saya nak suruh buat tadi? Alright.
Calculator.
Dash checking for calculator.
Dash checking for this calculator. Okay, so construct a dash checking for 2 sets of data. Okay, for this algorithm. And then submit to Kalam. That one is for your attendance for today. Boleh? Dash checking?
Boleh, sir.
Boleh
Boleh, sir.
Boleh, sir.
Any last question?
Sir, can you show us the calculator slide again?
Calculator slide. Which one? PowerPoint.
Yeah, the one that you want us to do dash checking.
This one. This is the algorithm. This is the algorithm. So you need to do dash checking for this algorithm. Nampak ni? Yang sebelah kiri ni. Okay, this is the algorithm. Construct a dash checking for this algorithm. Okay, so what you need to do is you list down the test data. Okay, set 1 apa, set 2 apa. Okay, set 1 input apa. Okay, for example set 1 input apa? Number 1, 1. Number 2, 10. Okay, set 2. Number 1, 15. Number 2, 30. Okay, expected result. For set 1 apa? So you manually calculate. For set 2, you manually calculate. Okay, get the result. And then construct the dash checking. Make sure the result, the output result is similar as expected result. Okay, for this one. Get it?
Yes, thank you, sir.
Okay, so we meet again during lab session. Okay, we are going to discuss a little bit on the last week punya exercise. Okay, just maybe 30 minutes labs. Okay, so check out your lab schedule based on section lah. C11 lain, C12 lain, C13 lain. So I will give the link later on for the lab. Boleh? Okay.
Boleh.
Alright.
Boleh.
Okay, if dah tak ada question Okay, thank you. Assalamualaikum.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Waalaikumsalam. Thank you,
Thank
Dr.
you, sir. Waalaikumsalam.
Thank you, sir.
Thank you, sir.